Hello, dear students. This is Professor Pino, and now we are going to speak about matter and measurements. What is matter? Matter is anything that has mass and volume. And remember that mass is the amount of matter and volume is the space that it takes. Don't confuse mass with weight. The weight depends on the gravitational pull on a mass. If I put you in the moon, you weigh less. However, you have the same mass. If I cut your arm off, you have less mass and weight and blood pressure. Okay. Then we can classify matter into pure substances and mixtures. Remember that all the matter is made of atoms and molecules. Pure substances can be elements or compounds. For example, gold, oxygen are elements, and compounds are made of two or more elements. Mixtures are made up more than one substance. They can be homogeneous or heterogeneous. Well, a pure substance, as I told you before, can be the elements and the compounds. What is the main characteristic of a pure substance? Well, a definite and constant composition. You cannot separate them physically. And they have distinct chemical properties. Here you have water that is made of two atoms of hydrogen and one of oxygen. Diamonds are made of carbon. Table salt is made of sodium and chlorine. And sugar contains 6 atoms of carbon, 12 of hydrogen, and 6 of oxygen. Well, a mixture does not have a fixed composition as pure substances. A homogeneous mixture has the same composition and properties throughout, though the composition of different homogeneous mixture may be different. For example, we have soda pop, salt water, 14 chelate gold, and many plastic are homogeneous mixtures. For example, the 10K and the 14K gold have different composition, but both are homogeneous. A heterogeneous mixture can have a different composition and properties from one part of the mixture to another. For example, here we have different types. It is very important to distinguish between a physical property and a chemical property. A physical property is displayed by the same, but a sample of matter without undergoing any change in the composition of the matter. For example, the mass, the color, the volume, the temperature, the density, and the melting point are physical properties of matter. A chemical property is displayed by a sample of matter as it undergoes a change in composition. Pay close attention to this. For example, flammability, toxicity, toxicity, reactivity, acidity, all them are chemical properties. When you burn ethanol, well, it will be converted into carbon dioxide and water. Then you are changing the original composition when you are measuring the flammability of the ethanol, for example. What is a measurement? Well, it's a quantitative observation. In order to be quantitative, you have to make the comparison of the object that you are measuring with a standard. Of course, it's not any kind of a standard. It is a standard that everybody agreed with this. Every measurement has a number, but at the same time has a unit. And I will stop into here because it's very important for me that you answer your question using the number and the unit. For example, you are measuring a ruler and you say, oh, it is 30 centimeters. Then you have a number and a unit. What is precision and what is accuracy? Well, here we have three samples that will be useful to understand it. In this case, in the last one, it is precise and accurate. Why? Well, look, here in this one, all the arrows goes very close, then it is precise, but not accurate because the actual value is here, and then it is far from the actual value. In this case, it is not accurate nor precise. Okay? Because not accurate because they are far from the actual value, and not precise because the values are far one from the other, not so close as in this case. Is precise because all the measurements are very close to a number. Well, now you have an idea of what is precision and what is accuracy. In order to do measurements, we need a system of units. In the United States, we use the metric system as everywhere in this world, but also we use the English system. Well, the metric system comes from, or the international system, sorry, SI, comes from the metric system. And it has simplicity and is based on a 10 or multiples of 10. We have 7 units. We are going to see them. Here are the 7 units, but we use in chemistry only this group: length, mass, temperature, time, and amount of substance. The unit of length is the meter. The unit of mass is the kilogram. The unit of temperature is Kelvin. We are talking in the international system, of course. The unit for time is the second, and the amount of substance, the mole. Here are the abbreviation of these units, M, K, G, K, capital letter, can you see? S, lowercase, and more lowercase. For length, as I told you before, the basic unit of length is meter, and is represented by a lowercase m. What is the length? Is the distance between two objects, and you can measure it, for example, using a ruler. We make use of prefixes for units larger or smaller than the meter. Let's see the different prefixes. For example, kilo, that represents 1,000. Deci, that represents a tenth. Centi, that represents 100. Milli, that represents 1,000. Micro, that represents a million. And nano, that represents a billion. Here are the exponents that we can use in the conversions for every unit. Well, if you use different instruments with different scales, look, in this case, this scale is more precise. So you can give in your answer 3 significant figures. In this case, you can give only 2. It's less precise than this one. And in this case, only 1 significant figure. What are the rules for counting significant figures? First of all, you can see that the significant figures depend on the precision of the instrument that you are using. In this case, we can say that when you don't have zeros, all the numbers are significant. And this number has 4 significant figures. 1, 2, 3, 4. In this case, the zeros to the left are not significant. So this number has only 3 significant figures. In this case, you have a 0 that is in between. Then we call this captive zeros. In this case, this 0 is significant. So this number has 4 significant figures. The trailing zeros can be significant or not. If you have a decimal point, then they are significant. In this case, you have 4 significant figures. Here you have different examples. As you have a decimal point, this 0 is significant, and then you have 5 significant figures. Same thing here, but not here. You don't have here a decimal point, so this 0 is a trailing 0, and you have only 5 significant figures. When in scientific notation, you don't consider this significant because they are trailing zeros. So this number has 1, 2, 3 significant figures. In this number, the zeros to the left are not significant. So you have 1, 2 significant figures. In this case, you have only 2 significant figures because you don't have decimal points, and then all these zeros are trailing zeros. They are not significant. So you have only 2 significant figures in this big number. If you say 5 dogs, well, this is a counted value, and we say that this is unlimited. rounded. Well, this is not new for you. When you are going to skip numbers to the left, you have to see this. If the next number or the last digit is less than 5, you drop the number. But if the next digit is 5 or greater, you increase by 1. In mathematical operations, for example, addition and subtraction, the best way is to put the numbers one below the others. And you observe the number with least significant figures, and then you do your operation. But at the end, you only report as the same number until the number with least significant or decimal spaces. In this case, the first number that you're going to skip is lower than 5, so you round until 2. In multiplication and division is different. You say, here I have 1, 2, 3, 4, 5 significant figures, and here you have 2. You say, this number has less significant figures. So you do the operation and you say, well, I have to report until here. But as the first number that you're going to skip is higher than 5, then you round up. And the answer will be 4.6. Two significant figure as the number with least significant figures. This is very important. If in your answers you don't report the correct number of significant figures, then you're going to lose points. And it is not at this point, it will be until the end of this class. Well, what is dimensional analysis or dimensional analysis? Dimensional analysis, also known as factor label method, requires us to use ratios. For example, you can say that 24 hours is 1 day, 12 inches is 1 foot, or this number of atoms is 1 mole. These equivalences can be used to write conversion factors. For example, you say 24 hours is 1 day, or you can say 1 day is 24 hours. Which one of these conversion factors you are going to use? Well, depends on, and I will explain you right now. For example, here we have different conversion factors that we can use in the from the English to the metric system, or from, as you can see here, 1 inch is 2.54 centimeters, 1 pound is 454 grams, and so on. If you want, you can take note of these conversions, because maybe you have these in your homework, for example. Well, what is the dimensional analysis? Well, this is the starting amount, and then you say the inches this is the given number, this is the given unit, then in the conversion factor, you use inches down in such a way that you can cancel inches with inches, and then the answer will be in foot. That is what you are looking for. Then you multiply 24 by 1 and divide by 12, and you get 2 feet. In this case, the answer is incorrect because you are given only one significant figure and the given number has 2 significant figures. How can you give the answer correctly? Well, if you say 2.0 feet, then it is fine because this number has 2 significant figures as the given one. Here we have another example. How many yards are in 52 feet? This is the given number, and it has 2 significant figures. Don't forget that. What is the question? Well, you want to know how much are 52 feet in yards. And you know that 1 yard is equal to 3 feet. Then you can make this conversion factor or this one. Which one you are going to use? Well, as the given number is in feet, then you use this conversion factor that has feet down in such a way that you can cancel feet with feet, and the answer will be in chart. That is your question. Then you cancel out feet with feet. You multiply 52 by 1 and divide by 3, and your answer will be this one. But now you have to be careful with the number of significant figures. If the given number has 2 significant figures, as you can see here, your answer must have 2 significant figures too. So you skip the first number and you give only as answer 17 that has also 2 significant figures. Well, that's all. I know that I went a little fast, but you can watch this video several times and stop it until you understand what I have explained you today. See you soon.